Welcome to this explainer. As an astrophysicist, I can tell you firsthand that our universe is just filled with infinite wonders. And right when we think we've got the rules of the cosmos all figured out, it throws us a massive curveball. Usually we think of planets in pretty simple terms, right? They're either dense, rocky spheres like Earth, or massive gas giants. But today we're going full documentary style to explore a recent discovery that completely upends those traditional models. We're talking about objects that literally defy common sense and stretch the absolute limits of astrophysics.
Okay, let's dive right into this. What if a planet was actually lighter than cotton candy? It sounds like some kind of sci-fi fairy tale, doesn't it? But we've recently discovered two very real planets that fit this exact, seemingly impossible description. They go by the official designations TOI 791b and TOI 791c. And let me tell you, these aren't your standard terrestrial worlds or typical gas giants. These two exoplanets are forcing us to completely rewrite the textbooks. Because their density is so extraordinarily low, they challenge the very physics of what a planet can actually be. To really wrap our heads around this bizarre mystery, we've got to look far beyond our own cosmic neighborhood. TOI 791b and TOI 791c are located a staggering 1,110 light-years away from Earth. They reside out in the Volans constellation in the southern sky. Out there in the deep dark, they're locked in an orbit around a sun-like dwarf star. Honestly, just trying to imagine the sheer vastness of that distance, it gives you a real sense of the awe-inspiring scale of our universe. Plus, it highlights the absolutely incredible technology we need just to spot these worlds in the first place. So, astronomers actually have a very specific, almost kind of playful classification for this strange type of world. We call them super puff planets. These are extremely rare cosmic objects with a density so remarkably low that, well, if you could somehow fly a ship up close to one, they'd appear almost hollow or maybe even somewhat transparent. They are essentially giant puffy clouds just barely holding themselves together as planets. It completely challenges everything we thought we knew about planetary formation, because how on earth does an object get this massively huge in physical size without accumulating the dense mass to match? Think about the last time you had cotton candy at a fair. It's basically just spun air, right? The density of standard cotton candy is roughly 0.05 grams per cubic centimeter. But get this, TOI 791c has a density of just 0.047 grams per cubic centimeter. And its sibling, TOI 791b? It's even lighter, at an astonishing 0.038 grams. This isn't just some fun little analogy we came up with. It's a mathematical fact that these massive celestial bodies are literally lighter and less dense from the cotton candy you buy at an amusement park. Absolutely wild. Let's put that incredible lack of density into a real planetary perspective. In terms of physical volume, the actual space they take up in the sky, these super puff planets are huge. They're very much akin to Jupiter, the undisputed heavyweight champion of our own solar system. But their mass, it is drastically lower. Imagine taking a balloon the size of a skyscraper and filling it with just a tiny handful of air. That is the kind of scale and mass disparity we're talking about here. Like I said, they're essentially just giant hollow shells of gas. In fact, I really want you to remember this staggering number, 28 to 35. Despite having a physical volume that rivals the largest planet in our solar system, these super puff planets are 28 to 35 times lighter and emptier than Jupiter. That makes them some of the most bizarre, downright inexplicable giants in the entire cosmos. They're like cosmic ghosts, taking up a massive amount of real estate in their star system while containing barely any actual material.
Now, what's really interesting here is that the strangeness of these planets doesn't just stop at that cotton candy density. To fully appreciate what's going on, let's do a quick physics tutorial. We need to understand the mechanics of planetary orbits, specifically how these two lightweight giants interact gravitationally with one another as they circle around their host star.
The whole key to their orbital relationship is a physics concept known as mean motion resonance. Basically, this is a precise gravitational rhythm that happens when two orbiting bodies get locked into a mathematical ratio. They end up exerting this regular, periodic gravitational influence on each other. Think of two pendulums swinging in perfect sync, or two dancers moving to the exact same beat. Their gravitational poles are literally keeping each other in a stable, highly coordinated lockstep over millions and millions of years.
So how does this play out for our cotton candy worlds? Well, TOI 791b and c are locked into a beautiful 5-to-3 orbital dance. This means that in the exact amount of time it takes the inner planet to complete 5 full orbits around their host star, the outer planet completes exactly 3 orbits. Imagine watching them from above.
You'd see two massive spheres tracing elegant circles, visually syncing up like the gears in a giant cosmic clock. And every time they reach these milestones, they give each other a little gravitational tug, reinforcing this perfect 5-to-3 loop. I absolutely love this quote from the researchers studying the system. The perfect rhythm of gravity dictates their orbital time. It's a great reminder that the universe isn't just random chaotic noise. Sometimes it operates like a finely tuned watch. This 5-to-3 mean motion resonance is just a beautifully balanced cosmic mechanic. It's the exact thing keeping these two incredibly fragile, puffy worlds totally stable as they travel through the void of space.
Which brings us to the next obvious question. If these planets are essentially invisible, hollow ghosts floating over 1,000 light-years away, how on Earth did we actually find them? This is where our story shifts into a bit of a cosmic detective hunt. Because discovering these worlds wasn't just about big telescopes, it was a massive triumph of global collaboration and pure human curiosity.
The very first hints arrived back in 2019. This was thanks to initial data from NASA's TESS satellite, which is constantly monitoring the sky for tiny, almost imperceptible dips in starlight. By 2023, further test data confirmed that these tiny dips were indeed repeating. But, satellite data only tells part of the story. The crucial final step took place over the months that followed. It required intense, relentless ground-based transit observations to finally prove beyond a doubt that these massive, lightweight planets were actually real. And what I find absolutely amazing is the human element here. Yes, a multi-million-dollar NASA satellite provided the initial raw data, but algorithms didn't solve this mystery all on their own. It was ordinary science-loving volunteers, citizen scientists scanning through mountains of public data who actually spotted the crucial clues. They were the ones who flagged the weird dips in starlight. Only then do professional astronomers jump in to follow up on those brilliant leads. It's just incredible proof that there is a very real, vital place for everyday people in modern astrophysics. Now, to actually confirm those leads, professional astronomers had to utilize one of the most extreme scientific facilities on the entire planet, the ASTEP telescope, located at Concordia Station in Antarctica. Why Antarctica of all places? Well, because the long, incredibly dry, and crystal clear polar nights provide some of the absolute best stargazing conditions on Earth. But to study these delicate super-puff planets, scientists had to brave some of the harshest, most unforgiving conditions humanity can possibly endure. As the researchers described it, the confirmation required months of intense transit observations in freezing isolation. Just picture that for a second. Researchers bundled up in the perpetual night of the Antarctic winter, enduring temperatures far below freezing, completely isolated from the rest of the world, all just to watch a distant dwarf star blink as a cloud of cosmic cotton candy passed in front of it. It adds such a rich, human flavor to the extreme lengths we'll go to for the sake of scientific discovery.
So now that we've found them, what are they actually made of? The primary mystery here is how their atmospheres can be so remarkably opaque, yet physically so incredibly light. The data tells us that these worlds are composed heavily of hydrogen and helium. It's this specific, highly abundant mixture of the two lightest elements in the universe that creates their puffy, hollow nature. But exactly how they manage to hold on to this vast envelope of gas without it just blowing away into deep space, that is still a massive puzzle.
So the crucial point to take away is that our investigation isn't over. Not even close. To solve the final mysteries of why these super-puff planets are so opaque and to figure out exactly how their atmospheres function, we need a bigger magnifying glass. And that brings us to the next frontier, the James Webb Space Telescope. Scientist Amaury Triot from the University of Birmingham, along with his dedicated team, are currently preparing to turn the immense power of JWST toward the Volans constellation. By using advanced spectroscopic analysis methods, they're hoping to peer directly into that hydrogen and helium fog, decode the light, and finally unlock the remaining secrets of these worlds. Which leaves us with one final, pretty profound thought. The discovery of these super-puff planets reminds us that we are really only at the very beginning of our cosmic understanding. Nature is infinitely more diverse and honestly more creative than our limited models suggest. I mean, if the universe can forge entire planets that are literally lighter than cosmic cotton candy, what other unimaginable, bizarre diversities are hiding out there in the dark, just waiting to be found? Thank you so much for joining me for this explainer, and remember, keep looking up.